Happy early birthday.
All right. Hello, everybody. How is it going? Hope everybody is doing well. We are picking up what we did last time. Did I? Let me see. I forgot to meant to update the go live notification. Sorry about that. My birthday was actually last week, but thank you very much for that. Let me update that now. Okay. Damon, it's good to see you. How are you doing? I'm doing well. Smudge, thank you very much for the 200 bits. I really appreciate that. Yeah, it's actually, I guess, belated instead of early. Yeah, we're doing a normal link stream tonight. I just forgot to change the go live message. So, but yeah, birthday was pretty good last week. We did quite a long stream last week, and we actually got a lot done. And as you can see here on the screen, I got even more done. Where we have both of our different types of fonts working again. So yeah, yeah, Smudge, that's more on me than anything. I forgot that I had put that in there for the go live message. So I almost never change it. So the fact that I did last time, I forgot to actually change it back. But yes, my birthday was last week. But yeah, thank you very much for the 200 bucks. I still greatly appreciate that. So thank you. So yeah, birthday celebration was good. Spent some time with the fam. Had a lot of fun. And yeah, I just kind of I did a little bit. I did a little bit of stuff later in the day afterwards. But yeah, I haven't really touched this stuff since. So I just kind of again took a little bit of a break from it to come back to it tonight. So that's more or less where we're at tonight. So let me just take a quick second to, before we move on, to thank the supporters of the channel, starting with our partners, and they are the highest tier of subscription over on YouTube memberships and Patreon. They are Furkan Tokan. I hope I'm pronouncing that right. Gabi Bashir and Gerboli's Inc. I would also like to thank the other supporters listed here on the screen. They're a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated. It helps me cover expenses with the project, hosting, things like that, equipment costs, that kind of thing. So thank you very much for that, as well as all bits tossed on Twitch. I greatly appreciate those as well. And I hope it goes without saying that I appreciate each and every one of you, the viewers, whether you're catching this on VOD later on or you're catching it live. Here on Twitch or on YouTube, we do simulcast to both. So if you guys want to stop in and say hello, feel free. I do keep an eye on both chats, and I'll answer any questions that come up to the best of my ability. Let's see. So Joa, have I ever heard of a game called Sparkmutts? I have not. But what I'll do is I'll pull that up in a off-screen tab, and I will look into it off camera. I assume it's probably on Steam. Yep. Okay. So yeah, I don't want to get like DMCA'd or anything, but yeah, I'll have a look. Is there something that you're wanting to mention about it? This is it here. Just steampunk world full of smart dogs. Okay. Yeah, it looks like it could be interesting. Coming soon. Okay, it's not released yet. Okay. Sparkmutts mentioned. I've not heard of this one actually. Is this is this one of those that I should be aware of that I'm not? Um, yeah, okay, definitely. I will. I'll hold on to this one for sure. Developed by a Brazilian. Well, even more reason for me to look. Yeah, I'll check it out for sure. As much as I can check it out, anyways. It looks like it's not released yet, so I don't know if they have any demos or anything like that. But um, very cool. Yes, I will check that out. Okay, so to provide a little bit of context as to where we left off. So up until this point, for the last month or so, we've been working on a redo of our the way that resources are handled within the system. So we're replacing our old resource system with two systems, technically more than that, but high level two systems. So we have what's going to be called the K resource system, which is sort of the replacement for that. And that handles anything that is sort of uploaded to the GPU or used within the world, right? So it's like meshes, textures, things like that. And then we have an asset system, which is the sort of representation of that file on disk. So, it might be an image that gets used for a texture or an image that gets used for a height map, for example. That would be an image asset. And so those are distinct sort of operations. Those are distinct sets of things that need to happen. And so we were kind of doing all that very ad hoc. And we've decided to sort of unify that and, or I should say, de-unify that rather, or split it up into bespoke systems, right? And so we have that. And then underneath the asset system, we also built a packaging system in addition to a virtual file system so that we can actually have asset packaging when we go to actually ship a game. So we've got a lot of the roots of that in place. And we know that all of that stuff is working because what we did on the last stream, and I think we started on the stream before that, was we actually converted our font rendering to use the new resources, at least as far as textures are concerned, right? So both our system font, which is this guy here, and our bitmap font have been converted to use this, and they are working flawlessly. So we have that done. The next thing that we need to do is we need to go through our texture system and anything using the texture system and slowly swap all of that stuff from using the old sort of textures to the new K resource textures. And from that point, we can kind of get rid of all the old texture stuff out of the system and switch over to only using the new stuff. So we're basically tackling this one resource type at a time. We did font texture loading specifically for the bitmap font and the system fonts here. We did that first just because it was kind of an easy point of entry. The next one we're going to tackle is actually the texture system that powers all the rest of the stuff you see on the screen. So it'll tackle the meshes, the textures that the meshes ultimately use, which goes through the material system, as well as other stuff like the textures used by the water, the skybox, things like that. So we're going to kind of do our best to split those things up as we go, and go from there. But that's basically where we're at, right? Textures I picked to do first because textures reach into the most things in the entire system. So we'll do textures first. Then I'll probably double back and do the font resources themselves, which is the actual loading of like the true type fonts and stuff like that, because that's still kind of using some of the old resource stuff for the actual font specific data. So we'll probably double back to do that. And then, we'll do something like meshes next. And then the rest of them from there will really be pretty easy. So we're getting there for sure. We've made some pretty good progress. And the cool thing is that we see all of those fonts rendering, which means all of the systems that we've built up to now, that we've been building on top of, work. So at this point, it's really just a matter of converting everything over. Okay, so we did leave off in the font system here. What we need to take a look at is the texture system. So the texture system's got quite a few things that we're going to need to do in here. So we're going to have to talk about that a little bit and figure out what order of operations we should take. But for the most part, actually, if we look at the header file for this, just because it's a little bit simpler to look at this way. So the old sort of way of doing things was this acquire, right? Which would acquire a reference to a texture. It was sort of a instantaneous load, returned a pointer to a texture. And then we could set some flags like auto release. We could name it using a string, things like that. And then we also have the new way of doing things, which is a texture system request, which is an asynchronous way of doing it. And so what this does is right now it's all synchronous, but internally what's going to happen is it's eventually going to kick off a job, and that job will run against the parameters that we pass here. And ultimately what will happen is a callback will be made. A callback will be provided by the caller. And when that asynchronous operation is complete, this callback will be made, passing through some parameters. And we can then do whatever processing we need to with that resource. So that is more or less what we're looking at. Me and Mr. Mustard, how's it going? Am I on a Mac? No, I'm not. Well, not what you're looking at here. This is Linux. You're thinking you're probably seeing these and thinking Mac, right? Because the theme is a little bit Mac-ish, I guess you could kind of say. But yeah, it's this is Arch Linux, actually using the Cinnamon desktop environment. But I am streaming from a Mac, so my streaming machine is a Mac. So you're not completely wrong. Glad to see you in business. I appreciate that. Don't let them fool you. This is OS X. Yeah, I mean, yeah, it says Arch right there. Arch, by the way, Arch. But yeah, I am using, and actually we are probably going to have some streams at some point on Mac OS when we go to port some of this stuff over. Arch iOS. Yeah, the auto mod got you, Sulfoam, for sure. I don't know why I thought fool was a bad word, but there you have it. All right. All right, so more or less what we're doing is we're switching from this sort of acquire stuff to request stuff, right? So anywhere that we're doing a texture system acquire, we're going to change that to a texture system request, and then provide a callback. Now, granted, the usage of this is a little bit more complex, right? But it is far more flexible because we don't have to worry about, the life cycle of a texture and whatnot. When we're provided the actual texture in the callback, it's ready to go. So I think this way of working makes a little bit more sense. It's going to make everything a little bit easier to jobify. So with that, we already have this one, which replaces texture system acquire. We have some specialized versions of acquire, which is like acquire cube. That's just going to be a matter of, I think, just, basically passing through some extra parameters internally to convert that over. So I'm not really too worried about that. And then we also have a request writable, which is already done. That's what we needed for the system font. So that's done. Request writable array is done. So that's the replacement for acquire textures as arrayed. We do need to do release. Oh wait, no, we already have release. Never mind. Ignore that. Wrap internal is something we may have to do. I haven't fully decided how I want to handle this yet. The only thing that really uses this is the swap chain images in Vulkan, right? So essentially, those are created for us automatically internally by the device. We have no control over that. And so what we do is we essentially wrap one of our textures around those Vulkan images. And then obviously it'll be, just reworking all of the resize, write data, all that kind of stuff to handle the new versions of textures, right? And one thing I'm wanting to get away from eventually is the use of texture pointers everywhere. At some point, I want to get, instead of using texture pointers everywhere, I want to instead use handles, right? But we're not there yet. So to do this, we're going to need to do a few things. We're going to need to do, we're going to need to set up default textures for everything, right? So right now we have a default diffuse texture. We're going to need to set up some of these other defaults as well. So we already have kind of a framework in place for that. We just need to do that. That's probably the first thing we'll do. And then the other thing that we have is we have these texture references in here, which is hooked up to a hash table that's used to look up textures by name. It's used for our internal reference counting. We're not going to need the reference counting anymore because our resource system actually automatically handles reference counting for us. And so we don't actually have to do that internally here. So we're actually going to remove a lot of logic out of here that's handling that we no longer need, which is pretty sweet. So lots of good things. Let's see. Electric Lizard, first time chat, welcome. Would you consider shipping a binary? I see potential in Kohi as a real engine that you would actually use for development. We do intend to do that at some point. Realistically, that's probably not going to happen until we at least release one game on it. And we have an editor, right? Because right now you really do need the source code in order to be able to build a project against it, right? But that is the plan ultimately, is that we'll have, some sort of a binary that gets released with like a launcher that auto updates it and all that fancy stuff. You had a skill issue compiling Kohi on Linux. That can be, if you're not familiar with how to do it or the inner workings of it, that can be a task. Although I actually find it easier to set up a Linux dev environment than I do Windows. So looking forward to it. Awesome. Yeah, no problem. Excited to see you switching to the new K resource system. Yep. Yeah, so that's what we're doing tonight. We're switching over some more of our texture stuff and ripping out stuff we don't need. So, enough chit chat. Let's actually get into it. So, what I think I'm going to do is I'm going to put the old stuff down here, right? And we're essentially going to we already have that one. So we're essentially going to just take copies of these things. And I'm not going to rip the old ones out until we actually have everything converted. So we're going to say K resource texture, right? And then what did we do? I think we just put K resource in the name actually too. So we can actually rename these later. But for now, we'll do that just to keep them distinct, right? So this is the new, this is the old, right? And eventually we'll wind up getting rid of these. And then once we actually have, all of this stuff switched over, we are going to say to do remove this. We're going to do the same for this. And yeah, that's good enough for now. All right. So, and that's going to go for a lot, like a lot of this stuff is going to just disappear. I might do some build guide documentation for Kohi. I recently got it building on a fresh Linux install. That would be super helpful, actually. If you want, Smudge, what would be super helpful, actually, if you go into, I suppose you could do it against the 8.0 branch. Let me bring this over here so you can see this. If you go against the release 0.80 branch, and right in here, in the main README, we actually have like prerequisites, and I've kind of been messing with some of this stuff. But yeah, like we have prerequisites here, and then like building. I have a Windows and a Linux Mac OS because they're kind of similar. But yeah, if you could do that in here, that would be super useful, just so it's all in one spot. Second try compiling Kohi. I don't understand what this is. Number 236. What is number 236? Did you write up like an issue and that's the issue number, or this? Okay. Okay. So shader C is not found. So that's part of the Vulkan SDK. It's weird that you got so far with this, but I see you're building a release build though. I wonder if release builds are broken. Release builds are broken, but not where we thought they were. That's just an unused variable. Okay. I should probably fix that too, but I'm going to come back to that. Look lower, it was a journey. Okay. Required validation layer. Okay, your validation layers don't. And you're on 071. Okay. I'm not surprised some of these were failing. I know some of these were failing in 071. But these are just the unit tests. So, yeah, I wouldn't worry about this because we actually have to redo a bunch of those. So when you go to run it, you want to be running testbed, not unit tests. I would also say you're on 071 and or the main branch, because I think this is what is pushed to the main branch. Try also using the 0.8.0 release branch. Yeah, so this is just some unit tests that run. Like, we have a unit test framework that we set up for some stuff, some of which are broken currently, and those will wind up being fixed as part of this refactor. But yeah, the one you want is actually testbed. Helped a lot. All right, perfect, cool. Speaking of handles, the German word for chicken is Händel. Sounds like handle. That's funny. The ad for McDonald's new chicken sandwich was too hot to handle. That's super clever. I like that. Which is actually pretty funny because I thought like puns in German are kind of a difficult thing to achieve from my understanding. Let's see. Found a strange compiler bug. You're on the 35th episode and you tried to compile the engine with release mode. Yeah, so if you're using any sort of compiler optimization that early on in the series, it's probably not going to work. There were all kinds of things that we had that just were not right early on. Yeah, so I would not do that, maybe me. I would only use debug for now. Until you get much further. Yeah, because we actually had to wind up doing a huge pass against a lot of that stuff. Yeah, so use 0 because, yeah, it would work just fine. Looks like the issue with SIMD instructions because my matrices in VEC4 are using... Yeah, so I know that there's some stuff that where it tries to optimize some of those math operations into SIMD operations, and it doesn't quite do it correctly. So we haven't tackled SIMD yet, but it's a future thing for sure. Probably not before our first game release, to be completely honest. I don't think we're going to need it yet. Seen many pubs and restaurants that have puns in their names. Okay, that's interesting. Now that you've converted fonts and UI, it'll be easier to convert the rest of the textures. The only thing that I'm a little concerned about is some of the layered textures. But I'm not terribly worried about it. We'll figure it out, but yeah, we'll see. All right. So we need to default textures create. Okay. So if we take, you know what, I'm going to actually close that one. So if we take a look at sort of the way that we handle textures, right? We did have this create default texture sort of private function that we used. And that encapsulated a lot of logic, right? We have this create and upload texture that does all this stuff, right? This is all the deprecated stuff. And so when we're creating our new resource texture, we're kind of doing, again, a lot of steps. Now, this doesn't have quite as many steps in it. It's more configuring a structure and just passing that through. And then, you know, kind of kicking off the request here at the bottom. So I'm thinking probably we're going to have a lot of overlap here because we have sort of the default texture, which is that checkerboard pattern. And then we have, you know, a default diffuse texture, which is just a white texture, default specular, et cetera, right? So these are basically going to wind up being very similar operations, right? And so I'm thinking we can probably take all of this stuff and go ahead and include it in, you know, some sort of private function. One thing I do want to do, I'm seeing that we kind of put this in here. We probably should go ahead and include that in the actual system state. Where is that? Here. So let's see, that's the renderer system state. We also need the K resource system. So we'll just change that. And then in initialize, we can actually do state pointer, and we'll do what was that? Wasn't it K resource system? There it is. Okay. So we'll save the convenience pointer there instead of doing it all over the place, right? And then now all we have to do is, oops. There. All right. So I'm thinking we can just take this whole thing and I'm just going to create it here and then we'll move it. So static, I guess we can say B8 create default key resource texture, right? And we're going to need the texture system state for that. All right, and let's see, what are we going to need? So we're going to need some properties. We're going to need some pixel data, things like that. Now, I think this other version, create default texture, took in dimension, name, all that kind of stuff. So, okay, so let's do, let's see, I think this is a U32. Yeah. So let's do a U32 text dimension. Oh, it looks like we have ads. Let's break for that. Strangest thing about this is that access violation only happens when assigning a matrix and not constructing it. I checked everything in the debugger and it should work fine, but it's not. Very interesting. Yeah, I think ultimately what happens there is there was some sort of issue that I didn't find till way later on, where there was basically some stat corruption happening. But I didn't find it for a really long time because it didn't present for a really long time. So I didn't know it was an issue. It was either stack or heap corruption. I can't remember at this point, but I remember thinking, like, how the heck has this worked that long with that bug in there? We fixed it live, but I don't remember exactly what the issue was. Taman, I just noticed this 7 stream streak. Nice. Primate Burden, thank you for the follow. Appreciate that. If you were forced to use either polymorphism or ECS for your first game, which would you rather use? Why would I be forced to? Why would I be forced to do either? I mean, I guess I would lean more towards. I hesitate, like. I don't think I would do either, right? It would be like a decorator pattern or something if I had to do something like that. Hypothetically, I mean, if I had to choose one, polymorphism probably. But they're both kind of inherently evil in my mind. Does Kohi support FBX or only GLTF? It supports neither of those at the moment. It supports OBJ. We have to write importers for those other ones. We just haven't gotten there yet. Yeah. We're writing all this stuff from scratch, right? Including like our OBJ importer parser, all that stuff is all written from scratch, right? So FBX is probably going to be the first one that I do, followed by GLTF. Because GLTF technically has 2 different versions of it, right? There's a GLB, which is the binary of it, and then there's the GLTF, which is the sort of the JSON version of it, and those require different parsers. Okay, so let's take in, we have texture dimension, and then we have channel count. Are we ever going to have a non 4-channel default texture? Right, this is only internal when we're creating default textures. I think we can just say, we can just hard code that to 4, right? Because I don't see us needing to change that, right? I mean, I hate it though. I can't bring myself to do it. Let's at least say channel count instead of channels. Formats. Format, I guess we'll add if we need it. What we really need is we need a pixel array size, I think was a U32. Yes. So U32 pixel array size and void pointer. Actually, you know what? Let's go U8 pointer, right? Or U8 array. And we'll say pixels. Right? And so pixel array size just becomes pixel array size, right? It's just a pass through. All right. We also need the texture. So let's take in k-resource texture, out texture, right? And that's going to be the replacement for this, right? So this is going to be out texture. Failed to request resources for default texture. That's fine. We do need a name, so we should probably put that in like close to first, right? So kname, name. So let's do this. Name. And map levels I'm not going to worry about for default textures. I'm not really too worried about that. Okay. We don't actually need to do... We don't actually need to do this copy, because we could do that before we actually pass that into here, right? We're going to make the assumption that we're going to do that ahead of time. So let's change this to just pixels. And we'll remove the memory copy. All right. And then otherwise, we go return true. Right? And so now we can just call this guy create default K resource texture. So that would replace this one. If not, create default K resource texture, right? So we pass state. Name is going to be that. Texture dimension is just going to be text dimension. Channel count in this case is going to be, let's see, we have channels, right? So channels, we can just pass through channels, I suppose. Right? Pixel array size is actually going to wind up being this. So I'm actually going to take this line and do that, right? So that's going to wind up being, oops, just that. And then we'll pass through, I think it's just called pixels. Yes, so pixels. And then we're going to pass the address of state default K resource texture. Right, and if that whole thing fails, then we'll do this. Right, and then we should be able to, we should be good to go. So this all now gets clobbered, and we just do that instead. Let's see. Q3's MD3 format. Yeah, that's another one that I should probably support at some point. GLTF keeps getting extended. Yeah. Yeah, and that's a bit annoying too, for sure. Might you have a single channel font or opacity mask? A single channel font or opacity mask. Oh, are you talking for like a default texture? I mean, these are textures that we use as like fallbacks in case we like don't have a texture for something. So I don't think so. Oops, this should be down here. Yeah, so this function right here is only internal. So I don't think it's going to be a problem. It'd be easy enough to extend if we needed to, because the only place we're actually going to use it is within this create default textures function. So I think we'll be okay. Let me just make sure that this one works as is. That we don't get any foo bars. I think we're good. All right. Perfect. All right. So I know we're getting some validation on shutdown. I'm going to fix all of those at once, I think. Okay. So we can get rid of all this. Right? And we can just come through here and essentially tack on to all of these places where we're actually creating these textures. So I guess what I'll do is, let's do it this way. We'll say default texture, and we'll just scope this, right? And then we'll say default diffuse texture, right? And we'll scope this, and so forth, right? That'll just make it a little bit easier for when we go to remove these defaults later, like sort of the old defaults. It'll make it easier to just kind of come through here and do that. And then we don't have to worry about like duplicated names or any of that kind of stuff. Right, so one here and one right here. Okay. So what we're going to do is in tandem, we're going to create the old style texture and then the new resource style texture. So we can come down here and do this. Let's see, creating default resource texture. So this is, we actually don't need the second trace output there. Let's actually move this one up here. And we'll just kind of keep that as the pattern going forward. All right, so pixel array size is gonna wind up being the same thing. The only other thing I think that we need to change is this needs to be default diffuse texture name. And this will have to be default, what do we call this? Default diffuse K resource tech. Did I get that wrong? I probably did. I should have put the K resource in later. Screw it. It's fine. I'm going to wind up renaming these anyway, so I'm not really all that worried about it. So I guess we'll do diffuse texture. And just realize that's behind my head. So we'll change the name of that. All right. That should be it, right? So it's going to be just a matter of taking these. This is going to be the specular texture. Oops, yeah. Let's see. All right, so we have that. The default normal texture. All right. I forgot to change the error message. This should be, which I almost got rid of the specular texture because we're not really using it, but I am going to wind up putting the Fong pipeline back in at some point, just so the user has a choice. Ban the spammer. Let's see. Replaced your texture generation with red checkerboard. Love red checkerboards. That's fair. What I wound up doing, though, is I use a red checkerboard as the default for my cube map texture, right? So I have like, or I'm going to have different defaults for different sort of, or different colors for different sort of default textures, if that makes sense. Wait, no, I did that one. Okay, so that's normal texture. So let's take this and come down here to combined. This is something I'm going to be redoing at some point as well, is this combined texture. I like the way that it works on the rendering backend, but I don't like the user code. So the combined texture is, for reference, it is the roughness, metallic, and AO maps combined. Since those are only each require a single channel of data, it's those maps combined. But the problem is that it requires those to be sort of mashed together in the actual texture that gets loaded, which is not great. So one of the things that we might do in this refactor is the ability to actually take those from separate assets and merge them into the same map, which is kind of the usage that you might expect from the end application anyway. So combined. So the aspect, or, you know, the idea of a combined texture might actually be going away. Cube texture. Okay, so this one is going to be. This one's going to be a little bit different. Because this one's layered. So I do see here that we have a create default layered texture, which again just calls to create and upload texture. Oh, and see, we actually had stuff hard-coded in this one even, so I don't actually feel too bad, right? Like that's the channel numbers, for example. All right, so this needs to be create default. Maybe we should make this create default resource texture like layered by default. And maybe we just pass 1 to it everywhere except here. And that would probably get us what we need. I just realized that we also are passing the wrong pixels array in a few of these. So that's combined pixels. This is normal pixels. This one is spec pixels. This is diff pixels. I think this one's just pixels. Yeah, okay. So this one's going to be terrain pixels, right? Okay. So pixel array size is going to be layer size times layer count, right? So that's essentially what we're doing here to allocate this array, right? So layer size is correct. Okay. Oh, we're actually using we're reusing some of those pixel arrays by default. Interesting. Okay. I'll have to fix that in a second. See, there's also some like hard-coded rubbish in here that I don't like the per material map count is hard-coded, which I'm not a huge fan of either. I kind of wonder if this should even, if this default texture type should even be a thing. Let's see. Have you thought about what feature you're going to work on after you make the first game? Oh, after the first game? No, I'm not that far ahead yet. We do have a whole to-do list, right? And I do have stuff flagged for future releases. So things out of this list, things out of this list, or things out of these generic lists that aren't even prioritized yet. So we have plenty of stuff to choose from. Let's see. 200 maps for one asset, doable with a texture array. Yeah, that's true. I mean, it's you know, like a multi-sub object could have that easily. Okay, how do we want to do? So let's call this well, first off, let's change this. We are going to need a layer count added to this. So I guess let's fix that real quick. We'll do U8 layer count, right? And array size, well, I guess layer count? Yeah, that's fine. Array size is going to be layer count. We may also need to add texture type too. Right, so layer count comes in after text dimension. So layer count needs to go there. And then up here, basically just need to add 1 for all these. Oops. There, there, and there. All right. So that'll cover our layers. Wait a minute. This says cube texture. Oh, wait a minute. Oh, there's 2 things going on here. I was like, why does that say cube texture, but it's actually talking about terrain texture? Default terrain texture should be here, right? So we actually missed a step. We need to handle the default cube texture as well. So this should be cube texture name. And the create default cube texture. What is that actually using for its pixel data? All this stuff. Okay, so let's just take this straight out of here. All this layer logic and all this other stuff. Right, and we'll do it, we'll do that right here. Okay, so here's where we create all that pixel data. This is going to be, let's see, cube side pixels. So that's for an individual side. Oh, pixels, it's just a pixel array. Okay. So we can do that. And then we also need to do need to free this, right? Oops. Pixels. Make sure we don't leak that. Okay. I think that should pretty much cover us. We need to change this. Default cube texture, which I think, let's see, default combined, normal. Okay, I think we did get all of these. Yes. Okay, so this one, did we get this one? This is going to be default terrain texture, which is actually kind of a misnomer because it doesn't necessarily just have to be for terrains. And this is one of the reasons I'm thinking like maybe this default shouldn't even exist. Like we might have, we maybe should just have like a default layered texture for like certain numbers of layers. We did this just to sort of act as a fallback for our terrain materials, right? But I'm not so sure that this makes sense. So I'm actually going to stick a to-do in here. This should be a default layered texture of n layers, if anything. Wow, you're really making a game in C from 0. Me too, but it's just mine's not that complex, just 2,000 lines and it works on the command. Nice. Yes, we are making a full game from scratch. In fact, we're going to make several games from scratch. So we've written the game engine from scratch. That's what we're working on right now is the engine. But we're getting ready to actually switch gears and work on the first game, which is going to be a relatively simple game. You know, there's not going to be a whole heck of a lot to it. We already started sort of coming up with let's see, we already started kind of coming up with a design document for it, right? So we've already started kind of prototyping some ideas here on stream, right? So we've got some ideas, but yeah, this is one game of several we're going to make using this engine. That's a lot of stuff. Yeah, and that to-do list is not exhaustive either. But there's some of those things that are like going to be checked off kind of at the same time. Some of those features intertwine too. So it is a lot of stuff though. Like, and part of the point that I want to drive home with this is it is a lot of work, right? But it's possible. Takes a while, but it's possible. All right. So we need the normal pixels and the combined pixels. So I'm going to have to hoist those up, unfortunately. So let's take the combined pixels and we'll just move those there. And then the normal pixels and move them there. All right. That should do it for the default textures, I think. No, there isn't one more thing we have to do. We need to pass the texture type. So when we create our default layer texture, it's a texture 2D array, right? Most of our textures are going to be just texture type 2D. But the layer texture is a 2D array, and then the cube is texture type cube, right? So we actually need to add one more property to this, or one more argument rather. So we're gonna do, I guess right after name, right? So name, type, dimension, like we just kind of get more granular as we go. So let's do k-resource texture type, and we'll just say type. And then instead of hard coding this, we're just going to say type, right? And so for this one, this is going to be k-resource texture type 2D array. For the cube map up here, this is going to be k-resource texture type cube. And incidentally, the number of layers for that is going to be 6. And for the rest of these, actually, texture type 2D. Right, so we can kind of go up here and anywhere right here, we could just plug that in. That one, that one, that one. Okay. Wait, what? Why is it bleating? Unused variable pixel array size. Line 904. Right. We don't need this one. Okay. Built. So Joshy, if you're still there on the YouTube side, I'll quickly show you like some of what we have. Because what we've done so far hasn't really changed much of anything, visually speaking, for a bit. We're kind of working on some low-level systems level stuff now at the moment. But yeah, this is kind of what we have at the moment. You know, as far as like features in the engine, right? So we've got a basic PBR system, you know, ability to load meshes. We can select objects and move them around the world, manipulate them. You know, we can rotate them along various axes and so forth. You know, so we can do all that. And then also we have water that we added somewhat recently. So that still needs some tweaking. It's not perfect, but you know, it's there. Here's the Sponza scene that everybody recognizes as, you know, your sort of quintessential testing object. You know, we've got basic skyboxes, LOD terrain, things like that, right? So this is a debug build, so performance on this guy isn't so great because we have Vulkan validation layers running, which are quite heavy, right? And so those do add a little bit of weight to all the processing that needs to be done. If we were to turn those off, you know, it would be a lot faster, but we need those running in case we screw things up at the moment. So yeah, that's pretty much where we're at, though. Okay. What is the name type? So you're talking about this this type here, the kname create. Is that what you mean? Okay. So what this says, K-names are essentially just the type def of a U64. And what this is whenever we have a K-name, we create it by passing in a string. That string is then hashed into a U64 unique, sort of a unique ID, right? Based on the content of that string. And so what this allows us to do is we can create this K-name from a string and use that for in place of string comparisons, right? So instead of having to do string comparisons all over the place, you create these K-name objects, and now you're just comparing integers. So the way that this works is when you do a K-name create, there's an internal lookup table that's created that keeps the original string that you created the K-name with. So if you go to use that string again, it doesn't create it more than once, right? But it allows you to have a sort of unique integer representation of the string across the system. And it makes lookups very, very fast. So you can use a fast type internally, but interface using a string. Yep. Yeah. And one thing that we eventually want to add on to this is eventually we're going to do some sort of compile time strings. So right now this is all runtime, but at some point we're going to write a utility to actually have the ability to sort of pre-process the code, and anywhere where there's, I think we're probably going to do it with a macro. Anywhere where we're creating a K-name with like a specific macro, so it might look something like K name, I guess like this, and then, some string, whatever, right? Anywhere you basically do that, under the hood, it would call this, right? But it would call it at compile time. And it would, essentially it would bake it in, right? So we don't have that bit yet. We just have the runtime version of that. But already that's proving to be super useful. Because now all we have to do, we don't have to care about string lifetimes, right? We don't have to worry about checking for null strings or string length or any of that crap, right? All we have to do now is we just have a K name, and every named resource and eventually in the engine is going to be converted to use these. And all we have to do is just worry about having one of those, right? And that's it. And an invalid name is 0, right? Which is the default sort of value that you get when you allocate a block memory, right? So, you'll never get a hash of 0. And so, that's essentially the way that works. Did you write your own hash algorithm for that? I did not, actually. I used CRC 64 for that. Yeah. That was not something that I wanted to spend that much time doing. So there is a CRC 64 in here that has all of the credits from the initial people that wrote it, right? This is one of those things where I'm just like, I don't want to spend the time looking into this. Yeah. It's a simple solution, but it works. Yeah. And it's fast. Okay. All right, so we have our defaults. We have our defaults created anyway. I guess what we should do is we should probably do releases against all of these, right? So where we have these destroy textures, we should probably also have, I think I can actually just probably get away with doing this. So K resource system release, right? And what else did that want? Needs the state and the resource, right? So we need state K resource system. And then I believe we're going to have to, we have to actually use the right one. And then I believe we're going to have to actually cast this to a K resource pointer. Okay. So, I guess the first step of this is actually going to be to make sure we're grabbing the right ones all the way down. And then we'll cast all of these. So K resource pointer, right? And then we'll do K resource system release all the way down. And then we also need state K resource system. There we go. All right, so old, new. Cool. So I think that's going to be the first part of it that we need to do. I do see that we do have some stuff in here regarding like a combination of cube textures and stuff. I'm not going to worry about those for right now. I'm just going to start, I think, switching over our basic 2D texture types first, and we'll get the other ones after. We're actually going to wind up having a lot of stuff to get rid of, which is going to be good. This stuff may wind up going away too. Okay. Resize I'm not going to worry about for right now. Release resource, we already have that. We should probably go ahead and hook up this default check, right? So whenever we release a system texture, right? And actually, this is going to be good, right? Because I can actually show the K-name stuff here. So whenever we release an old style texture, right? We release it by name. And we have to do this string equal I, right? And I had this to do in here, check other default names as well. But now all we can do is literally say, you know, is this a default texture? And we could just look at the name and say, hey, does this match the K name that we have for these things? So let's go ahead and we're going to extend this function a little bit because we probably should be checking this, right? So we can do, let me think about this. Probably the best way to do it. Every part of me wants to go with a switch, but I don't think that's going to be the right way to do it. So what we can do is we can just say if, and then we can just take the T, and then in the base type of that, we have the name, which is a K name. And we can just do equals. And we'll do state default K resource texture. Why is that not giving me... Oh. Because I need that. And then I think it was just name. Okay, wait. Oh, that's the resource system state. So a lot of our new, this is another thing that we're kind of changing around as well. So texture system H. If we take a look at request, wait a minute, we don't actually have it there either. I guess I could just do a fetch of the title of the state. I guess that's fine. Let's call this resource system, and we'll do texture system state equals engine systems gets texture system, right? And then this should be resource system. This should be, why is this bleating about? Oh, because it's not a pointer. I think this needs to be dot base name. Right, okay. If I can get my stuff together tonight. So instead of having to do like a string equal I, right, and then pass the default texture name and the name, right, now we can literally just do a double equals check and it's all integers, right? So it's lightning fast. And so in this case, I guess we could do, I'm just trying to think, I guess it would be fine if we did a switch statement around this, right? I guess we could do, this, right? Which is the other thing, because we couldn't do that before. Can I do this? I think it's got to be constant, though, for me to do this. I don't think I can do this still. Yeah, because that's not a constant expression. I have to stick with if statements. But if we had those as constants, we could do that. Base name. Okay. I almost wish that I had like a array of these things that I could just loop through. Right, because the ultimate operation I want to do here is return. Right, if it's a base texture, I want to return. If actually, I'll say do nothing if this is a default texture. That makes it so that we can't release default textures. Trash can, how's it going? Long time no see indeed. Used to get notifications on Twitter when you were live, but I can't anymore for reasons. Fair. Oh, right. They shut that down in Brazil, didn't they? Yeah. I have opinions on that, but I'm not gonna state them here. AT Override, how's it going? Just started learning C fully, have a Java background, but excited to make the switch and make it my native lang. Awesome. Welcome to the party. Welcome, welcome. We always need more C peeps. Twitter's down in Brazil. Yeah. Yeah, womp womp. Let me think. I guess there's always the Discord role. Right? You're on Discord, so you could get it that way. There's a server notify or stream notify role on the Discord server that gets pinged. You're constantly traveling to Argentina virtually, but it's not the same thing. Yeah. How long have you programmed in C, and what career fields and what advice do you have? Fair enough. All right, so excuse me. I have more, believe it or not, I actually have more C++ professional experience than I do C experience, which is one of the reasons I don't use C++ for my personal stuff, because I have the experience to know not to use it. But a lot of my C++ always wound up looking very much like C, with a few exceptions. I always called it sort of C++ light. So I was kind of writing C-ish code for a number of years. Professionally speaking, that was about 5. Personally speaking, it's about 20. But I switched to full-time C for this project. And that started a little over 3 years ago. So, yes, push toy. You're not wrong, and I'll accept that. But yeah, I've been at it for a while. C++ mentioned, yeah. It was like C+, only one, yeah, C+, right? I wanted to make C minus minus, but all right. I guess we're gonna have to do this the poopy way, because I don't see a better way to do it. So I guess we're just gonna have to do, this kind of. All right, and I'm just gonna slam in a bunch of these, and we're gonna say this is gonna be default diffuse texture, right? Default specular texture, and default normal texture, default combined texture, default cube texture, default terrain texture, we really need to rename that. I think those are the only defaults. Yeah. So we do this one. Right? And I guess we could probably even say, is this default? And create a function for this if we need to do it more than once. But we all know the best C-based language is Holy C. I mean, I can't say it's wrong. I can't say it's right either. Oh, I just saw the hydrate redeem. Thank you for that. 35 minutes late. I'm in the zone tonight, I think is part of the problem. Singy, how's it going? Good to see you. Me and Mr. Mustard, I'll see you later. Thanks for joining. All right. So release should be good to go. I guess the next thing to do is anywhere that we are calling texture system acquire, we're going to need to start doing a texture system request instead. Which I think I put like up here somewhere. There it is, right here. So we're basically going to have to replace these with these. So I guess we'll do texture system acquire. There's not actually too many. And some of these are going to be cube maps and stuff, so that's good. Oh, and some of these might be string error messages, which is also good. Any of these in texture system.c we can actually ignore. So actually, we really don't have that many of these. Font system one's already been clobbered. And in fact, that's probably the one, that's probably what we'll use as a example. So really it's just the skybox, the water plane, and the material system. Actually, it looks like it's all that's using that. So I guess we'll check out the material system, right? This is a little bit more loaded than it looks, though. So there's two parts to this. So this is in a, first off, this is in a private function that's being called from a few different places within the material system. So what this basically does is it says, I have this texture map. Here is a material map configuration, or a configuration for that texture map. Here's the name of the material, and here's the default texture to use if you can't do the thing. And then it uses texture system acquire, but it's also using our old texture map type. So we're going to have to change that too. Now, the material map config, if we take a look at that, I believe we did actually create new types for these. I'm not 100% sure. We might actually be able to use the material map type, though, as is. We might actually get away with that. We'll have to see. But so what this does is make sure that we have a string first. If it does, it uses that texture name to perform a lookup. This immediately gives us a result, though. So that's one thing to consider. The request is not going to do that. And then we say, hey, if we don't have the texture, then we use the default texture. So I'm thinking we might actually be able to get rid of this default texture business, because the way that the renderer is going to be set up to use these is it should say, well, hey, if I don't actually have, if this texture isn't loaded, it should be using sort of the default stuff anyway. So we might be able to get rid of that. And then it goes through and it acquires texture map resources, and then that's it. So with any luck, we can actually maybe rewrite this without too much of a hassle. Because I think this is the only place that actually uses this. Yeah, it's the only thing that uses texture system acquire. We did see that there's other acquire things in there, like the like cube maps and stuff, but we can kind of skip those for now. Let's see. A few days ago, I tried using. You used Objective C++. Wait. Objective C++. I know Objective C, but Objective C++ is a thing? What is... Objective C++ is simply source code that mixes Objective-C classes and C++ classes. Oh, okay. This is kind of what we're doing. This is what we're actually doing in our macOS layer now. It's just the C++ version of it. Okay. That's... Wait. Deleted but archived documentation on Objective-C++. Is it one of those things that they just deprecated? Huh. Okay. Yeah, I mean, so what we do in our macOS layer is we use this .m file, which is like mixed, right? So it's half Objective-C and half C. And you can just mix and match them. Yeah. You can then blend C, C++, and Objective-C. So it's just like a different file extension then. Okay. I mean, this is already kind of gross as it is. So how bad could it be? Terrible. Terrible, I'm sure. Dr. Elliott, good to see you. How are you? We're talking about awful Objective-C things at the moment, apparently. Yeah, I mean, I'm not a fan of Objective-C, but, you know, sometimes you just got to do it. I mean, it's not that bad to have a @property std vector, right? Right? Yeah. Ugh. I think I'm about to lose my dinner. All right. So what we're gonna do is we're gonna assign. We're gonna rewrite this assign map. Actually, let's see real quick. How many places call this? 10 places call this. Well, okay, not 10 places call it. There's going to be, one of them is going to be the function definition, and one of them is going to be the declaration. So we have 8 calls to it. Okay. Not a huge deal. I just think there's probably going to be, a bit of a Fallout refactor for this, I think. So let's grab this, and instead of outright replacing it, you know what? I'm not going to operate side by side. Screw it. I'm gonna outright replace it in this guy. All right, so this needs to be k resource texture map. We're gonna try to keep the config for now. We're gonna see how that works. Ooh, material name. Okay. So why does it need material name? I'm guessing just for debugging purposes. Also adds. All right. good. I could use a break from talking for a second anyway. No problem, Coffee Lava. I got your back, bro. I know you hate missing content. Nobody likes that. We're almost done with ads anyway. This timer actually says it's almost 40 seconds, but it's actually a little less than that, so I'll probably just cut it off early. How are you doing, by the way, Coffee Lava? What are you up to? And when are you going to stream again, dang it? I know I keep harassing you about that, but I genuinely did enjoy watching your streams. You streamed yesterday, and I missed it? What the heck? I didn't see a notification for that earlier today. Oh, that makes sense, though. I was slammed with work. I couldn't really watch a whole lot of stuff, unfortunately. All right. I'll have to... Are you planning on streaming again anytime soon? By the way, for you guys that don't know what I'm talking about, if you're not following Coffee Lava on Twitch, go do it. Everyone loves Coffee Lava's streams for some reason. He did yesterday. Game looks good too. Yeah. I definitely need to hop in there then. I like Coffee Lava's streams because he's a Giga Chad. And he's a real bro. Alright. I'm going to do... I'm going to take a K-name in here. And then, if we need it, I'm going to do K-name string get material name. Let's see. So, this obviously is not going to match what we have up top. That's why it's bleating there. But the good news is I think I didn't actually swap out these types. I did not. Good. So I don't have to worry about converting those because that'd be super annoying. Soul foam. I'll allow it. Only because you said these nuts. Are you working on the engine or the first game? So I'm still working on the engine. We are in the middle of the resource system refactor, but we do have like a visual progress update on it. So if I run this, we now actually have our fonts are actually showing up correctly. So these fonts are making use of our new resource system, our new asset system, our packaging system, and our new VFS. All of that stuff from end to end, as well as all the other fixes that we put in place. So the fact that you're seeing these is proof that all those systems are actually working. And then now what we're working on is we are swapping out the material system, all the calls to get textures from within the material system. We're swapping that out, which is all this stuff you see here. That is going to be moved over to the new system next. That's what we're doing now. Yes, I do watch Tokyo Spliff. Yep, I was in his chat for a minute today. Yep. Actually got him. Got him. Soulfoam getting modded, classic. I mean, if Soulfoam didn't get modded, I would be concerned, though. I would feel that if Soulfoam wasn't getting modded for something that, you know, he's slacking a little bit. Slipping, you know? Alright. So map texture. This is going to be where our choir is going to be changing. So I think what I'm going to do is actually go. Thank you for the follow. Appreciate that. Let's see. That's a request writable. I don't want that. This is what I want. And actually, this is the entirety of what I need right here. All right, so this is the old way of doing it. And then this is the sort of new way of doing it. So we have to do, let's see, config texture name. So we're going to have to do a kname create on that. Okay, so package name by default. What do we do for that? That brings up an interesting question. Because do we default to a package name, or do we just pass 0 and just say use whatever is the first one we can find? Which is actually kind of what I'm leaning towards. I feel like maybe the material should have some way of specifying that. That might be a future enhancement. Within material config. And this is going to be use the resource from the first one. Wait, how do I want to word this? Brain fart. Use the resource from the package where it is first found. All right. So the request. See, I guess for the listener for this. So we're going to have to think about this too. After we perform. So before what we were doing is we were acquiring the texture, and then we'd come down here and we'd say, okay, well, if we don't have that, we fall back to the default. I don't think we're going to need to do that anymore. Let's see. And then we would do a acquisition of texture map resources. I'm actually thinking we don't need to do any sort of callback on this. I think we can just let it do what it needs to do within the resource system. I don't think we actually need. So I'm going to do no listener, no callback. I don't know that that's going to work. I may have to rethink that. But the texture it's going to use is going to be the, let's see, map texture. Oh, I have to cast that to k-resource. What is repeat UVW? So that is the repeat mode for the UVW texture coordinate spaces, basically, right? So the U axis, the V axis, and the W axis. That's just kind of It's another way of saying XYZ. So basically what these are if we go into these, right, it's either repeat or mirrored repeat or clamp to edge or clamp to border, right? So it just specifies how that texture repeats if it has to tile, right? If you exceed the bounds of, 0 to 1 texture coordinates, what does it do on that given axis, right? So most of the time you're only going to be using U and V, right? Because most of the time textures are 2D, but for 3D textures you can also specify W. All right. Why is this complaining? Oh, does that actually not want... Oh, that does want the texture type. Okay, I don't need to cast this. What was it complaining about then? Oh, map texture is... Map texture is already a pointer. That's an issue. Thank you for the follow. Are you working in a company right now? I am working for a company. I'm not working for a game dev company at the moment, if that's what you're asking. So my day job is completely different than that now. I did work in game dev for a number of years, but I left that industry because I got tired of working 70 hours a week. Working for the man, yeah. Yeah, it's actually not too far from the truth either, to be completely honest. So, but yeah, my day job is basically writing medical software. So yeah, it's not too far from that push toy, but yeah. Okay. So, the problem with this request is that ultimately the pointer that's passed here, the out resource, right, is thought to be the sort of owner of that resource, right? So we actually do within the K resource system, right, we pass again that out resource. That gets passed all the way down to here. So that in turn basically has all of this stuff that gets set, right? All of this stuff right here. And so the problem with that is it basically expects that pointer to be the owner, which I might have to rethink doing it that way. Because in this case, the texture map itself does not own the texture, right? It actually has a pointer to a texture. So the two ways that I could get around this would be either I have the map own the texture, which is kind of stupid because you could have multiple textures or multiple maps using the same texture. And in fact, we do have that, right? So we wouldn't want to do that. Or I would have to define ownership or handle ownership some other way. Probably within the texture system. So I might need to rethink this whole request just for that part of it. So what really I think needs to happen here is when we request a texture, this is going to vary depending on our usage actually. So in our font system, for example, when we made this texture system request, we were actually storing that we were actually storing that as part of like the font's data itself. Like we had the font texture next to the font texture map. And it makes sense to have that ownership there that way. But in this case, it doesn't really make sense to have that. If cancer detected, go beep, beep, beep. Yeah, I mean, basically, yeah, more or less. It's a little bit more involved than that. It's actually the systems that hospitals use. So it's quite a bit more involved than that. Okay. That's your medical software that you're capable of writing? That's funny. So the problem with this is, and the old way that we used to do this was the texture system actually had that internal lookup table that we've been talking about getting rid of. And that would actually own the texture, right? And then we would return, we could very easily just set this pointer to be that texture, right? I'm now kind of leaning away from doing it this way, which is something I hadn't fully thought out before I did this. Not a huge deal. I think that's the reason we went that way with the texture system to begin with, and that's why it returned pointers. So if we were to change texture system request, instead of returning a request result, to instead just return a pointer to the texture for now, that would get around this problem, right? But we'd also have to have that sort of same internal texture registry, which I guess is fine. It's not ultimately what I wanted, but we could also maintain a lookup of those using like a binary search tree or something. That's how the resource system does it. I hate to have two separate sets of lookups though. Technically speaking, the resource system really owns it, right? So I guess if we were to get it from the resource system, the resource system does request here. So I have to think about this for a second too. This might be an actual design issue that I need to fix before I go any further with this. So the way that this works is when we request a resource, this is considered to be asynchronous, right? Because we can kick off a job that happens in another thread. It does the thing, it does all the stuff that's required and issues this callback once all that's complete. So we're not going to have an immediate return of anything. But we do pass along the resource here, a pointer to the resource that owns it, right? Let me see something. So in the request, we just do a handle request, handler request. So if we take a look at, let's look at the texture handler, right? Right, so here's the request handler for that. And depending on what this does, this may issue an asset system request, or if we give it pixel data, that's available immediately and is loaded immediately. And then I believe we actually, in either that case or if we're getting like just an empty writable texture, I don't even think we're calling the callback here regardless. In either one of those cases. So we write the data here, we write the texture data here, but yeah, we never actually... Am I missing something? Did I not... Callback is never issued from here. It's only issued if we actually load an asset. That is not the way that's supposed to work. This hurts my brain. Hurts my brain too at the moment. Yeah, I think I have a design oversight here. Okay, so I think what I'm going to have to do is ultimately let me go back to we only actually store that stuff in the asset system. The actual resource system isn't doing it like I thought it was. I must have missed that step along the way. Okay. So if I want to avoid having to do reference counting everywhere, then what I'm going to have to do... Oh, wait a minute. Is this... Yeah. Register known handler types. Okay. So I think what I'm going to do here is we have the request, which is asynchronous. What I think I'm going to do is build a layer on top of that that has a... Let's see, we still have a release here. I think the request specifically... Okay, so what I'm going to do is I'm going to do something like this. I'm going to say B8 K-resource system acquire, right? It's going to take in this. Oops. It's also going to take in a K-name name. Let's see, do we need the request info? No. Instead of a B8, we're going to do K-resource pointer. And so my thought is we're going to check an internal lookup table, which we're about to create, to see if a resource has been loaded with this name. If a resource has been loaded with that name, we immediately return it. If not, we're going to create a new entry, a new resource entry with that name, return a pointer to it, but its state will not be loaded, right? It'll be uninitialized, just like this right here. And so that way, whatever is actually looking for it immediately has a pointer of something to work with, but that thing might not actually be loaded yet, which is kind of an expected behavior, I think. The only thing that might get a little bit weird for this is the request info to have to pass along with it, right? We don't necessarily always need that. We would only ever use it if we don't actually have a resource with that name loaded. So I suppose I could do this. Right, and then to do if resource with name exists in lookup table, return a pointer to it. Otherwise, create a new entry in the lookup table, return a pointer to it, uninitialized. Then kick off a request. Random question: if you are executing some OpenGL or really any render API, calls to bind buffer and shader programs, etc., is in an asynchronous fashion, but you need to bind other things elsewhere outside of that thread's scope, how would you properly handle making sure each part gets the correct shader programs and buffers it needs without them stepping on each other? So OpenGL is notoriously terrible with multi-threading. It gets really really hacky, right? There's no one-size-fits-all solution. You just basically have to be very, very careful with it. Yeah. It wasn't really ever designed with that in mind. So, yeah, I mean, you might have to... I've never actually tried multi-threading OpenGL, to be completely honest. The first multi-threaded render I ever wrote was a Vulkan renderer. Because Minecraft clone would be a good place to start. Yeah, probably. Might have to use Vulkan and enter simple. Yeah, I mean, that would be my answer, is you just use Vulkan. Okay. I'm just trying to think this through to see if it's going to be what we need, right? So I would imagine if we have in our state, right? Because all we have in here is handlers, which is not quite enough. So what we really need is a U64, or was it a U32 BST? I forget. U64, thought so. So we already do have a binary search tree that we've written. So we'll just use that. BST. Actually, doesn't our... We have ads. I'll just pause the stream while I'm looking for what I need. I guess just move the chunk rendering out of the asynchronous logic and just run it when the generation thread completes. That's what I would do. I would keep all of anything having to do with GL, I would keep that all in the same thread. You can multi-thread everything that happens around that, but almost done with ads. Guess this is a mistake that gets made when you switch from Vulkan to OpenGL. Yeah. I can't even imagine writing an OpenGL renderer at this point. Just because I'm so used to the Vulkan way of doing things and having that control that you would just submit render commands to Vulkan on a command thread, so it never really mattered. Yeah. You're using GL? The mistake is using OpenGL. Yeah, I mean, don't get me wrong. I used OpenGL for a lot of years, right? But I never tried to multi-thread the actual rendering code. Only because the initial overhead is smaller. Yeah, I found with Vulkan, though, that in the long term, the overhead is less with Vulkan, believe it or not. But that's very long term. All right, so what we're looking at here is this is what I did in the asset system, and I could have swore I did it in the resource system, and apparently I never did. So we basically just need to re-implement this for the resource system. It's not a big deal. So what we have is we have a max number of assets that can be loaded. We have a array of asset lookups. Those asset lookups are just a structure that looks like this. So it contains the asset, right? So this is, in this case, what owns the asset. We have a reference count, and then whether or not that thing should be auto-released. And then we have a binary search tree to use as lookups. Quick lookups by kname, right? So the key of the binary search tree is the kname, right? Which is where the kname also comes into giving us a lot of power, right? Because we generate a U64, which is the kname, we can use that as the key in our binary search tree. And so the great thing about this is that, it's a binary search. And so with that, searching by those names is very, very fast. And so what we do here is the binary node itself has that key, that's the kname, and then the value of that particular node is the actual index into this lookups array. So whenever we create a new one of these, we essentially look for a free index in the lookups array, create a new entry into this tree using that kname that's provided and the lookups index. And then, we set up a new one of these at that place. And then whenever we go to retrieve an asset, we essentially are able to just say, hey, lookup tree, give me the index of into this array, and then return the address of the lookup asset at that index, right? So that's more or less what we're going to wind up doing. Always wondered how people would submit render commands to OpenGL. I see now they're just global. Yeah. Let's see. It's ultimately up to the driver. Different cards might do different things. Different cards definitely do different things. And there's still bugs out there in OpenGL. And there's bugs that that exist out there that can't be fixed because people actually rely on them, which is fun. You just didn't want to set up Vulkan for it. I would say just bite the bullet, right? If you've written a few OpenGL renderers and you kind of know your way around that, bite the bullet and move to Vulkan. You'll be glad you do once you wrap your mind around it. It's not an easy climb, I'll give you that, but okay. So let's go to K resource system. And we're going to do basically this same thing. So let's put that right here. This is going to be renamed to resource lookup. Resource lookup. This is going to be K resource, and this is going to be. Do I want to use the word resource? I don't think so, because I feel like we have used that elsewhere, and there might be a collision there. So, resource itself owned by this lookup, right? That's what we want. The current number of references to the resource indicates if the resource will be released when its reference count equals 0. So we have that. We'll go ahead and into the state here. I guess we'll need all three of these things, really, because we need to know how large the array is going to be. So this is going to be max resource count, number of resources that can be loaded at any given time, and that should be configurable by the application, right? So resource lookups and BT node, we need to include the binary search tree, and then we'll use lookups of resources by name, by we'll say kname, right? So we have that. Let's see, do we have anywhere in our config? I don't think we're actually even reading the config, which is, yeah, we just have dummy. So we're going to actually get rid of this dummy value here, and we're going to say max resource count. Knew we were going to need that config for something. Okay, so we'll say state max resource count equals config max resource count, and then state lookups equals do we want to use our new array type for this? Yeah, I'm not really worried about it. All right, kallocate. We'll do size of, and that's going to be resource lookup times state max resource count memory tag array. Right. So we have that. And then our lookup tree, which I think was literally, we don't actually even, I don't think we actually do anything with that until we actually go to create our first node, if I remember correctly. Yep. Yeah. Okay. So I guess we'll zero that out for now. We'll say state lookup tree equals 0. Right. And basically the way that this binary tree works is it's just a tree of nodes, right? So this, if the tree hasn't been initialized, i.e. we have no nodes to put in it, then this just is going to be 0. And then each node that gets added to that, will have, each node that gets added to that, obviously will have a key, a value, and a left and a right, right? And the BT node value can be a bunch of different things, right? So we have a union for that, right? So it could be any number of these different types here. All right, so we don't bother creating the tree. All we need to do next is we basically just need to build kind of some of this logic in here into our request. Which let me see if we are. I'm kind of wondering if we should rework request and just not do this step here. I think I need to have some more thinking on this offline and come back to it tomorrow. Planning to support Wayland on Linux. Running games on native Wayland is so good. Yeah, we do have plans for it. It's on the to-do list. I just haven't gotten to it yet. X11 is absolutely not dead, though. Most windowing systems still default and use it heavily. It's definitely not dead. There's still a lot of software out there that does not support Wayland. Wayland still has a long way to go before it can be, a full-on replacement for X11. Yeah, I would definitely not say X11 is dead, not by any stretch of the imagination. That's like saying OpenGL is dead. So what I would say instead, though, right, so you're saying it's usable true, dead because no more devs are supporting it. Well, no, lots of people support it, right? They're not adding anything to it, right? So I would say deprecated is more accurate there, right? It's deprecated, but very much still in use. Just like OpenGL is not receiving updates, right? It's deprecated, but it's very much not dead. Yeah. And X Wayland kind of gets us where we need to be, at least in the short term. So in the long term, yes, I will be putting Wayland support in there. But for the short term, no, probably not. When do you think Kohi will reach a stable version to build games? So we have to finish up this resource stuff. And then, let's see. I do have a number of things on here. So all of this is the resource type reworks, right? These, I just split them out for like individual types, right? So that looks like a really long list, but we're already kind of in the middle of this. And we're also in the middle of this right now too. So like basically this whole thing, right? We have a couple asset packaging things to do, a few things for a couple of different types. Hot reloading, I could even say we don't necessarily have to start with that to start on the game, although we're going to want it probably pretty quickly. There's a few bugs and things that we need to fix and a few nice to haves that we need to get in here. Not all of this stuff necessarily needs to get in there. So not that far off, I don't think. I'm thinking probably another month or two max. Is what I'm hoping anyways, unless we run into something that's like really, really bad. But at least to start developing the game, I think that's probably what we're looking at. Because I'm planning on shipping this game on 0.8, right? So 0.8 has all of this that's going to be released with it, all that stuff, right? And then 0.9 will be afterwards, right? And so that'll probably be there. And then we've got even a 0.10 list started. And I think once we get most of what's in this list done, then we'll cut like a 1.0. But there's still a lot of stuff that needs to be in there that I can't necessarily call it 1.0 without it being in there. So we can start the game and even release a game on 0.8, but yeah. Do you have priorities assigned to these tasks? No, not at the moment. The only real priority is this stuff has to go in by, 0.8 release, which the game is going to require this stuff. The game's also going to require a couple of additional things that we need to put in. So it's also going to, let's see, where was that? We also are going to need some of this stuff too. Maybe not all of it, but this is kind of like some of the stuff we were talking about getting. Some of these things are going to be really important for, you know, the visual look and feel. These things are just visual. So like, again, to start dev, we don't need to do that, but like before we release it, it needs to be done. Same is true with a lot of these things. I would say animation system we absolutely have to have before we can start. That's probably the one thing out of this entire list we absolutely have to have before we can start. Particles I can add in later, but we have to have it before release. Static mesh LOD, we do need that. That's pretty important. But again, we don't need that to start development. Spline editor for roads, etc. That might be neat to have, you know. We are probably going to need that at some point. HDR tone mapping, I mean, that's something that could go up here with this, honestly. Right? That's kind of in line with all that. You know, things like controller support and resource streaming. Like, resource streaming is maybe, like a maybe. So, I mean, there's no, like, direct priority list, but, like, that's kind of where we're at, I guess. All right, let's see. Is this building Kohi your side job hobby? Oh, and don't apologize for the questions, by the way. That's totally fine. So yeah, this is like a hobby for sure. Hobby slash, I guess you could call it a side job. Yeah, I mean, I put almost full-time hours, or not full-time, almost part-time hours into it. So yeah, I guess you could call it a side job for sure. All right. So with all that being said, speaking of jobs, I do have to get up for my job in the morning. So with that said, I probably need to go ahead and end the stream now, just because I have to be up early in the morning. So let me find somebody to raid. Let's see. Hoping to find something that's like relatively kind of related. Let's see. There's an ASMR stream, ASMR programming stream, if you guys wanted to see that. Was kind of hoping to find. Oh, you know what? Here's an interesting one. This guy is actually doing some Commodore 64 game programming. I've rated him once before, but I'm going to rate him again because I think he's fairly new to streaming. But yeah, we're going to rate his channel. He's he's making a Florida Man game, which is epic in my opinion. Having been a previous Florida resident myself, that's super funny. So anyway, yeah, guys, thank you so much for being here. I appreciate you guys. And you know, we'll be back tomorrow with another episode. If you haven't already, I would really appreciate a follow and or subscribe over on the YouTube side. It helps me grow the channel, helps me reach more people. But yeah, without further ado, I will see you guys in the next one. Peace.